All right, welcome back. We are GAME3001 in the summer 2021 semester at George Brown. Artificial Intelligence is week 3, part 2 of our broadcast, and now we're into lab 3. So what are the goals of our lab today? We are 2 goals. I'm going to try and get to this one. We couldn't get to this one earlier in the first lab, but hopefully we'll get to it now with you guys. So we want to implement movement that incorporates both velocity and acceleration. We also want to move in the direction that the object is oriented. And then in the second goal, I want to make an obstacle or add the obstacle to the scene, and then use simple AABB collision detection with some primitive brake casting in order for us to detect the obstacle when we're colliding with it. Okay, so that's kind of what we want to do. And let's get to it. So the first piece, what I've asked you to do is go and grab the Lab 3 starter. Let's do that first. So I'm going to grab this again, and I've kind of already gone and done that. So if I go back up to here, you can see that I have Lab 3 starter, which is actually just Lab 2 from last week. So I'm just going to just extract, I'm going to use 7-zip and extract here. And what I want to do here is rename this thing to Lab 3B, first step. Then what I want to do is double click on Lab 3B, and I want to open the solution. And when we open the solution, remember, it's going to take a second for you to do that. And what we want to do is we're going to change from x64 to x86. It's going to take a second. Sometimes it takes a minute or so to enable our resharper C++. So that's why I took a little bit of a delay there. In our template, what we also want to do here is we want to right click on my solution, and I want to retarget solution. This makes sure that your solution is using your current version of the SDK for Windows, not mine. And the next thing is in docs, I want to change this README file so it doesn't show that it's Lab 2, it's actually Lab 3. Okay, so let's change that. So now it's Lab 3. Inside of, the next change is inside of your placing.cpp. Please make sure that when you scroll down to your GUI function, it says Lab 3, not Lab 2. Okay, so we're changing all these little things because we're moving from Lab 2 to Lab 3. And once we have those changes in place, right, those few changes, then what I want to do is I'm going to go and right-click on my solution, and I'm going to go create Git Repository. Again, in order for you to get this option, and I know some other people in the first lab did not have this option, you need to, in extensions, you have to go to Manage Extensions, and you must have GitHub extension for Visual Studio installed. If you don't have this installed, you won't have the option I'm going to show you right here, which is if you right-click on your solution template and you go to Create Git Repository, this is important to do because it kind of does it in one step. You kind of do this, and then I'm going to choose, where it says owner for me, I'm going to choose George Brown. And in template, I'm going to choose this template that's going to be GAME3001, which is in the summer 2021 semester, and it is Lab 3B, which is what we're going to call it. I'm not going to make it private, but you would leave this on because remember, in order for you to share it with me, you need to make it private and then add me as a collaborator. And then I'm going to click Create and Push, which is going to make my repository where I'm going to have all the stuff that you need. So hopefully you guys have the things that I've done. And for you to check that now, if we go here and let's look at George Brown, we can see that there is a Lab 3B. This is going to be where the final is going to be, this little project right here, Lab 3B. I'm going to grab this link, and I'm going to go back to our content in Lab 3, and I'm going to add a new web link, which I'm going to call Lab 3 Final. Okay, so that way you will have this solution as soon as we're done with it, which I'm going to put in just after the starter. So there's the starter. You can always start with this one if you wanted to learn how to do this. And then this is the final version. You can compare your version with my version and see if it's the same. This is the kind of the learning piece. All right, let's get to the next piece now. So now that I have, this is the lab that I want, what we want to do is to actually do the actual work. Let's take a look and see, can we run this thing now? And that's kind of the first thing I do. I kind of run it, make sure that it all works, and that kind of stuff. If I don't, then what ends up happening is I'm making assumptions that things are working when they're not, and that could lead me down into a position where I'm thinking it should work, but it doesn't work, and that's a bad thing. All right, so it's looking like it started, and now you can see that there's a little thing here, and what we had last week was when I clicked on the toggle, then it ran and it stopped. This is not C. This is kind of the beginning of getting you guys to be used to what it's like to move an object. It uses kinematic movement as opposed to dynamic movement. What we want is an acceleration. So in order for us to accomplish this, right, as an example, and again, I'm going to, what I want to do here is I want to make sure that we are, so let's go back to this, that we're doing things properly. We want to make it so that in the placing.cpp, where we have a move starship function, we're going to remove that function and we're going to add it to the starship itself, because well, that's where it should be. Otherwise, can you imagine what's going to happen is that, well, the starship is always going to be limited or dependent on the scene. And we don't want it to be scene dependent. We want it to be scene independent. So what I want to do right now is I'm going to comment out this move starship. And I'm also going to comment out this part right here. And in the placing.h, I'm just literally going to copy this, move it down here, just make some adjustments. And I want to comment this out here. So we're going to comment it out for now, but later we're going to fully remove it. So that's how the thing moved before and no longer, right? Because that, well, that doesn't make any sense for it to be limited to the scene. We're going to make it so that it works all the time. In order for us to do that, we need to set up changes in our starship itself. So let's bring the starship, the starship itself in the game objects. So starship and starship.cpp. Those are the two things we need to move and work on right now. So what I want to do is think about what starship is going to do, right? So first things first, right? I want to add a move function, right? Because right now in my starship.h, there is no move function, and I want to port that over to my starship itself. So here, what I'm going to do is I'm going to say private movement variables. That's what these are. Okay, and we're also going to have some private member functions. And the only one I really care about right now is this m_move function. Okay, what I want is for the move function to be generated through resharp or C++ right here. And I want to call this move function, for now at least, every update. Okay, so this would be calling it every frame, and we don't have to do this anymore in the start scene or in the play scene. It's just going to be done regularly. So that's the first thing I want to change. Now let's start populating the move function itself. So the first thing we do is set up the move function, and then we have to implement it with all its lovely details. So what do we do there? Well, let's start off with first things first. We want to calculate we want to compute the direction and magnitude, right? Of the target. So the target direction and magnitude. And so for that, we can set up an auto variable where we'll call that target direction. And we'll say that the target direction is equal to get target position. And we're going to get transform, not rigid body, get transform position. So that's something we want to do. We want to say that we want to subtract the target position from our current position. But wait a minute, the target position, we've never really set the target position, so that Starship would never know what this is because we've never done this. Let's fix that problem. So that's inside of placeScene.cpp. So in placeScene.cpp, where I want to go into the set the target position for the first time in start. So again, in start, what I want to do is m_p Starship, and I can say set target position to m_p target get transform dot position, which is going to basically feed the target position to the Starship externally from the scene. We want to do the same thing anytime we change the target's position in IMGUI. Remember, whenever we change the target's position, we make the ship seek to the target. Well, we can't do that if we don't give it the new target position, because we're not doing it here in the scene anymore. So we have to do that in here as well. So all I've done is copied this from line 70 down to here into line 99. So now we have the target position going into the ship. Next, in the starship.cpp, once I have the target position, I can calculate the full magnitude of the direction, okay? The full magnitude of the direction. And this would be some kind of a number of pixels. So if I was to print this out really quickly, let's actually use this little example up here that I have left over as a remnant. I can do a cout. Instead of desired velocity, we can say target direction. And the target direction is going to be these the target direction x and the target direction y. So we want to print those out and see what that looks like. Every frame, I want to see what the target direction is. This should be in pixels. And one thing also to note is we never really set the direction of the Starship. That's one thing we found out in the first lab. We never set the direction. So what we want to do here is to fix that problem early is we want to set the current direction. The current direction is a float. No, it's really current heading. So I keep on fixed. I want to set the current heading and it's a float and I want to set it to 0. All right, because setting the current heading to 0 sets up a direction vector of 1, 0, because 0, by the way, if you remember what that looks like, oops, that was a bit of a drawing I did earlier. What it looks like is if I have my target here and I have my ship here, and if I'm pointing here, then what it's going to look at is, if you notice, this is what it's looking at, and this direction from an X and Y perspective is, if you print it out, is 1, 0, where the normalized direction would be 1, 0, because it's 1 across the x-axis and 0 up and down the y-axis. Why this? Normalization means we take the total magnitude, which means, let's say for our ship initially, it would be something like, remember we did this, 200 and 300. That's our ship's initial position, right? And then we have our target's position, which is 400 and 300, if I'm not wrong, or sorry, I think it's 600 and 300. Yes, that's what it is. And if that's true, then the difference between these, if we subtract this vector from this vector, the 300s cancel out, giving us 0. And the 600 minus 200 gives us 400 pixels of magnitude. But that doesn't make any sense. That's what we're getting when we do this calculation right here. We get the total magnitude in my target direction. Target direction gives us a massive magnitude of 400 pixels. And that's what we should see here, 400, 0. Let's see if that's true. So run it. And when I go start, then we should see 400, 0, right? And if I change this, if I change the distance to my target position, if I do this, you can see that that changes the direction. It changes the direction in terms of exactly what I put here, right? The difference between where I am and where this is, okay? So if I go over here, you can see that that will change the total direction, all right? And that is in pixels, 45 pixels to the right and 118 pixels down. That's the direction vector. But we want to normalize this so this becomes from 0 to 1, right? So the way to do that is the next thing. Let's skip down. We'll keep that direction. And we'll say that we want to normalize the direction. And normalization, remember, takes the total magnitude and use that as a divisor for the total for each component. So if we say something like target direction now is equal to, we want to use the util library, util, and we want to say normalize, and we want to pass in the target direction again. So what it does is it sanitizes this number from 400, 0 to 1, 0. And if I look at that and run it, now it's going to give me a normalized coordinate system from 1, 0. So 1, 0 is here. And if I was to move things around again, let's say move things closer, or if I go up here, that is the normalized coordinate system between -1 and 1. We're going to get a new thing where it says, I want you to go 0.95, not quite a whole unit across the x-axis, but there's going to be some kind of unit across the y-axis in the negative direction, which is up. Okay? And that's great. So that is my normalized target direction, which is what we need. That's fantastic. Next, what we want to do is we want to compute the target rotation angle. The target rotation is what we want to rotate, almost like the desired rotation, okay? So just like it says here, the desired velocity, we're kind of doing the same thing, but I'm breaking it up step by step here. So let's do that. So say the auto will say that this is the target rotation where we want to go to. We haven't done this rotation yet, but target rotation then is going to be equal to a util, and we're going to use something called a signed angle. And signed angle takes two things. It takes the current direction, so we can use get current direction, and then we can also pass in the target direction. So that get current direction, remember, if I go to definition for agent, right, we can see that in agent.cpp, get current direction returns the current direction. But when we set the current heading earlier, right, we change the direction by using this little formula. This looks familiar. This little formula is exactly kind of what we did before, but what's going to happen is as we change the current direction, the actual image is going to change or rotate as well. How do I know that? Because in the starship.cpp, when I draw the starship, I use the current heading, which is an angle, right, to change the starship's direction to every frame. That's what's happening. And when we use the target rotation, that is where we want to be. We haven't changed anything yet, but that is where we want to be. I also need some kind of turn sensitivity. So I'm going to say auto turn sensitivity. And this sensitivity is like, okay, imagine if, I'm going back to my drawing board here, I'm here, but what if my object was slightly above? And what would have to do is it's going to create jitter, because I'm going to try and turn towards my object by less than 1 degree, and then it's going to move in that direction, and then it's going to turn back, and it's going to turn 1, and it's going to turn back and turn 1. And so what we can do is we can change the sensitivity, almost like, so I don't want to make a change in direction unless it's greater than a number, right? So I can say that the turn sensitivity, and this is an adjustable number that we can use. We're going to use a value of, and this is something we can play with or hack around with, 5.0f. For now, we can do that. Later on, what we may want to do is adjust our turn sensitivity to make it so that it is more or less jittery. And the way it works is if we can say if the absolute value of the target rotation, right, if it is greater than the turn sensitivity, right, that means that when I say the absolute value, so if I'm going to get a turn rotation that's positive or negative, and I'm going to check to see if this value is greater than 5, whatever that value is, negative, positive, or negative. And if it's greater than 5, then let's turn. If it's not greater than 5, then don't do anything. Go in the same direction. And this is going to make us a little bit less sensitive, than before. Again, this is just a value that we can play with. We can actually put this inside of IMGUI to make it more or less sensitive. Let's try this again. So if then my target rotation, right, if it's greater than 0.0f, that means we want to initiate some kind of positive turn, right? If, on the other hand, my target rotation is less than 0.0f, well, then we want to do some kind of negative turn. And I say positive and negative turn because we don't know what's going to happen. Let's make a little output here. And then we're going to say that, we're going to say turn in positive direction. Okay, that's what we're going to do. We don't know what the positive direction is at this point, but we can use a little output to say that we're going to turn in the positive direction when our target rotation is greater than the turn sensitivity. Okay. However, what about if it's less than? We want to turn in the negative direction. And one thing to point out is I did it this way because what if it's something else? Notice there is no else. That means that we're not going to turn if it's less than 5 degrees, kind of thing. So it's going to make it less jittery. Okay. All right, so let's see how this works. So let's run this the way it is. And if I run it and I start it, then you're going to see it's going to say target direction is 1, 0, and it doesn't give me anything to do because the distance between the target and this, or the direction between the target and this, is not greater than 0 or less than 0. Let's make that happen. I'm going to bring up the IMGUI window here, and let's just change the direction. So it's down here, and it says turn in positive direction. So that means I want to turn to the right. And if I was to put this up here, it should say turn in negative direction, which is going to put me to the left. So that's what it does. It turns positive or turns negative based on where the position of the target is. Right? And again, it'll work the same in if we're back here, turn in a negative direction. And if we're down here, this should be turn in a positive direction, down this way. Okay. So that is what this does. So let's change our current heading. So when we're doing a positive turn, we actually add a couple things. So what I want to do here is now I want to say something like set current heading. And my current heading is, I'm going to get the current heading. I'm going to start with whatever the current heading is, and I'm going to add the turn rate. Okay, that's what's going to happen there. And that's if I want to make a positive rotation. If I want to do a negative rotation, so turn negative, then I'm just going to subtract it. And when I do that, if I just stop there, then when I run it, we should see the object turning. So going back to this, I start, and when I actually move the object, if I move it up, it should turn the starship in the direction that I'm moving. If I go over here, it's going to turn the starship wherever I am. It's going to continue to look at the target no matter what I do. All right. This is great. It's a great place to stop because we've added, the ability for us to turn in the direction that is the target. We're turning in the target's direction. So a couple things. I want to comment out the target direction. Let's comment this out. And because this is a little bit of noise for me, right? I don't know about you, but this is noisy, right? We're always showing what the target direction is. And what we want to put this up on GitHub. So let's go to Team Explorer. I'm going to go to Git Changes. I'm going to say that added move function to Starship. Okay, that's what we kind of did. And we also made this so it moves around, commit all. And then I'm going to push this up to GitHub. So you should have this. Are you with me? This is the next thing. So did you make this work for yourself? Does this work like how it worked for me? And again, I'm looking at our audience. We've got Ditting, Drake, and Julian, and Kenneth, and Kim, and so on. Are you guys good? Yes. Yeah. So what's happening is the move function is being initiated in our update function. So in our update function, move is being called, and that's how it's moving. That's how it's being called. That's how this function is being called. We have a couple of adjustments we can make. ReSharper is telling me to do a couple things. Target rotation, it says, should be const, and so should turn sensitivity, and I agree. All right, so turn sensitivity and target, these are all autos right now. We can make this different later, but for now, that's what it's saying. Kim says, I had a red line under move, but I forgot to put it in update. Okay. All right, cool. So we've done this piece, and now it's the next piece. The next piece is really what we want to do is in our, we want to start moving. So this is the rotation stuff. By the way, what we could do is we want to move is this part. So move is we're calculating the target direction, and we're calculating the this stuff. This stuff is going to directly impact the move function, right? Like the almost like look where you're going. That's what this part is, right? This is look where you're going, or we're actually doing face right now because that's all it's doing. It's actually moving anywhere. So what we could do, and this is something I didn't do earlier, is I could select all of these things, right? And what I could do is we could remove them from this function as an example, and we could put them inside of its own function. So if I go to refactor, I can go to extract, I can extract the method. And what I can do is I can call this some method. Right now it's called do work. That's not really cool. Let's call this method something like look where I'm going. Look where I'm going. Because that's what you're actually doing. So look where I'm going is basically, this is looking in the direction, it's getting the target direction, and it's calculating the rotation that I have to make every frame, right? So if I press this next, then it's going to create a new function that's going to be used here in move. So move is actually going to say, look where I'm going, okay? Here's the next part of move. By the way, we can break this out. First of all, it's going to still work, just curiously. And the reason why is because it's still doing the same thing in move. Move is being called by update, and look where I'm going is being called by move. So whenever we do this kind of thing here and I do this, then it's still going to work. Okay. Excellent. So now let's continue with the move function. So now we've isolated this part as look where I'm going, and now this part here is the move. Really, it's more like facing. I'm actually billboarding at this point. This is just billboarding every frame. Okay, but let's continue. The next part is I want to do the actual movement itself, and the movement looks like this. I want to get rigid body, and I want to change the acceleration, and I want to say that that is going to equal to the get current direction, because that's a vector, a normalized vector, and I want to multiply it by some acceleration rate. We don't have an acceleration rate right now. And why? Because the current direction right now is a normalized vector, so acceleration will be like really small. So you want to multiply by some kind of acceleration rate. And we don't have such a thing up here. We don't have anything like that at all. Let's make a new object to do that for us. So we're going to say that float m_acceleration rate. It's like a max speed equivalent. And acceleration rate is also going to need a getter and a setter. As an example, that's what we want for acceleration rate, right? And it'd be really awesome if we could just like refactor and then, do a getter and setter. It doesn't do that for us. It'd be awesome if it did, but it doesn't. So what we're going to do instead is we're going to make it manually. So we're going to say float get acceleration rate. It's going to be const. And then we're also going to set acceleration rate. And we're going to pass in a float that is an angle. A rate. Also notice that when we made look where I'm going is actually a not a getter or a setter. It is a public function right now. Let's leave it as a public function for now, but let's move it down. So we'll say these are public member functions, not getters and setters necessarily. They're like the same as getters and setters, but they have a different function, a different reason for being. Okay, so that's look where I'm going. But now we have set acceleration and get acceleration, and we need definitions for those. So I'm going to go to Starship, and I'm going to click the light bulb, and I'm going to go to generate definitions by declarations, which is going to say, do you want to generate the acceleration rate or set the accelerator? Do I want to generate these? And I want to say yes. It's going to put them inside of my starship.cpp. And now what we want to do is we want to say that when we get acceleration rate, we return m_acceleration rate. And when we set acceleration rate, we're going to say that m_acceleration rate is equal to rate. And of course, we can make this const. Okay, cool. So now that we have acceleration rate, what I really want to do is inside of our settings, when I talked about max speed and turn rate, what I want to do instead is not just talk about those, but also set the acceleration rate to some number. And I found that the acceleration rate should be set to around 2 to start off, just to play with. So 2 pixels per frame. So that's the acceleration rate. How things are it's going to get faster and faster, right? So then, now that we have the acceleration rate set up, we can go back to our move function. And we can say that the acceleration is the current direction, wherever we're looking, right? And we want to multiply it by get acceleration rate, which is going to give us a new vector that is 2 times the size of my current direction. My current direction normal. Okay? And that is the first thing. So first thing, we get the acceleration. The next thing I want to do is I want to start calculating you want to use the kinematic formula. So I want to use the kinematic equation, which is something you'll learn in physics. Again, for some people who have taken physics, then you'll recognize this, which is really equal to position final, which is equal to position initial plus velocity initial, right? times t, so that's time, plus 0.5 or half acceleration initial multiplied by time dot time. And typically what it looks like is this, right? That's typically the equation. One thing we're not going to do is we're not going to multiply acceleration. We're not going to do times time because actually it's going to make it worse. We can see the effect of this in a second because we're actually doing it inside of calculating delta time anyway. So this is something that we're going to kind of do over and over again. And sit on that, we need delta time. So we might as well make an auto delta time function. So delta time, and we're going to say delta time is equal to the game. We already have that. Let's include the game. We'll say the game instance, and we'll say get delta time. And we did that earlier where delta time calculates the ticks between frames. So we'll say as an example, it's roughly 16.66 milliseconds. So this is kind of a scalar more than anything else. This is what delta time is. It scales things down, actually. So we don't spam everything. And it also makes it so that our movement is scaled to the time frame, not to the speed of my computer. All right. All right, so the next thing that we want to do is, as we add delta time, is we're going to start thinking about what this is going to look like. And so how do I calculate this? So it's going to be like get rigid body, and we're going to say that the velocity, we're going to start with the velocity function, is we're going to add my get current direction, whatever the current direction is, the place where I'm heading, right? And I want to multiply it by delta time, right? So delta time is something I'm going to multiply it by. I'm putting it in brackets so you can see it. And then plus 0.5 f multiplied by my get rigid body, and then the acceleration that we just calculated, multiply that by delta time. Now, normally we do delta time and then multiply that by delta time again, right? But you're going to see that we probably won't need this. I'll leave it in like this so you can see the difference. I didn't do that in the first class, but you'll see that that is more or less what we're calculating from here on. That's this part, these two terms. Okay? So this is acceleration. This is the acceleration term. And this is the velocity term. But what we want to do is once we've got the velocity, we want to add that to position, right? But we also want to clamp it so it doesn't go beyond our maximum speed. And we can use another function for that. We can say that, so let's now clamp velocity, to max speed, because max speed will be the upper limit of how far velocity can increase. If we don't do that, this acceleration function will continue to add to velocity to infinity. It's going to go spin out of control. So we don't want that to happen. So what we're going to do instead is we're going to say that get rigid body velocity, we're going to just sanitize it a little bit. That's going to be equal to util. I got a little util function for you, which is clamp. And we're going to clamp the get rigid body velocity to max speed. Okay? So what this does, what the clamp function does, is doesn't allow velocity to go higher. The magnitude of the velocity can't go higher than the max speed. In this case, which is 10. Okay, that's what this does. And then once we have that, what we can do is we can add it to the position. So add velocity to position, which is the last piece. Okay, so this is the kinematic equation. What we're really doing here is compute velocity and acceleration terms. That's what we're doing here. We're clamping velocity to max speed, and then we're adding velocity to the position every frame, which is get transform position is going to be plus equals to get rigid body dot velocity. Okay, so that is the velocity is going to keep adding to position every turn, and it's going to be clamped to max speed, and that is your movement function. And that is using the kinematic equation to do that. So look where I'm going is actually a function that we're using. If I took look where I'm going out, this would still work. And we're going to see, I'm going to be able to check this on and off, and you'll see what I'm talking about in a sec. Let's try and see how that works. All right, so let's check it out and see what happens. So when we run it, and we press start, then you're going to see that it moves and it accelerates, and then it's going to spin around and keep going back and forth. And we can look and see if I move the location of my target, so let's say I move it here, it's going to go towards the target again. So whatever I move the target, it's going to try and get there. But you see it's like spinning out of control. You know, it would be nice if we had more control in IMGUI, so that way when it's coming closer, it can kind of attempt to get closer and closer. The reason why it's not coming back is because it's really moving slow. There it is. And it's trying to get back to it, but it's just not quite adjusted right? Again, what I can do is I can change the position of it in real time, right? And what the Starship is going to do is going to try to adjust to try and seek this out, but it's just not fast enough based on the parameters I've given it, right? So what we can do is we can give IMGUI the ability for me to add additional parameter control so that I can change things like not just seek, turn off. First of all, we haven't figured that out, but other things in IMGUI so that way we can get to this target. It's actually still doing what I've asked it to do. You just can't see it because it's off screen right now. Eventually, it's going to come back on screen, but it's going to take a bit of time. So let's fix that up. And the way to do that is we're going to do that work in IMGUI right now. So let's do that next. So I'm going back to the playscene.cpp, and in the IMGUI function, I want to add additional options, right? So that I can do different things in here, right? And this is what I'd like you to do when you make when you do your play scene, is add additional functionality, not just for now, but for everything in the future, right? What I mean is if I ask you to do something, IMGUI allows you to do a lot of troubleshooting that you couldn't do unless you did it in like hard coding it and try it and then relaunch and try it and keep doing it and try it. And it would take forever. So instead of doing it that way, let's not do it that way. Let's add some controls in here. All right. So the first thing I want to do is I want to start adding things for max speed. I want to change my maximum speed. I'm going to do that underneath seek. So I have a separator for that. That's fine. And underneath seek, and before I do target position, I want to add in a max speed. So I want to say static float speed. And I want to say that is m_p Starship. And that's going to be the max speed. So I'm going to kind of set the maximum speed of the Starship to the speed variable every frame. And then if IMGUI, and then I'm going to do a slider float. If my slider float max speed, if that's changed, then I want to take the speed variable and use that to go from 0.0f all the way to 100.0f. That's going to be the range of my max speed. Right now, it's going to be something like 10, right, starting off. So m_p Starship, I'm going to set the max speed to speed. And I'm just going to do one at a time here so you can see them. I know I'd done them a lot faster before this. I'm also going to add a separator between my speed and my target position, just to show you the difference between that. So let's add another separator. Separator is just add a line in IMGUI. Let's try this out and see what happens. So again, when I go back to IMGUI, you can see that I can add now a max speed. I can change the max speed. So let's make the max speed something like 50. And you can see it roar back over a lot faster, right? Because max speed, what it does is it limits the maximum acceleration. Now the acceleration is not going to be limited as much, right, to 10. So it's going to keep coming back into play. right? Again, what we can do is we can modify the x-axis so you can put it where it's supposed to be, and you can see that it's going to spin around based on the turn rate, and it'd be really nice if the turn rate was different as well. All right, so that's what max speed does. Similar to max speed, we can use another thing. I'm just going to copy paste here. I want to do one, and I can do the next one. Instead of speed, we can call this acceleration rate. Acceleration rate. And we can say that that is equal to the get acceleration rate of the ship starting off. We can call this acceleration rate. And we can use the acceleration rate variable to scale it. So we're going to go from the acceleration rate then again, can start off from 0 and maybe go to 50. Okay, and we'll set the acceleration rate here. So we'll say set the acceleration rate to acceleration rate. Okay, and now we have a second control. And again, I'm showing you this because people ask, well, how do I add stuff to IMGUI? What do I do as an example? And when I do that, you can see now I have an acceleration rate. I can increase the acceleration rate, right? And I can lower my max speed. So I can really go faster. But what I can do is when I lower my max speed, I accelerate up to my max speed really quickly. But you can see that now it's going to perform a little differently than what it did before. Now I want to mess with the turn rate, and that's the next thing I want to do. So acceleration rate, let's do turn rate next. So again, so copy this one, go here, and all we're doing is adding more controls to IMGUI so that it makes it different for us. So this turn rate, which is get turn rate. Yeah, there's a turn rate. Turn rate going to adjust these. And this is going to go from, again, this is an angle, so go from 0 to 20. Let's say, not much more. If it goes more than 20, it's weird. That's like 20 degrees every frame. It's like huge, right? If we go up that high. And this will set the turn rate. Set turn rate. Okay, so set turn rate. And that's this part. So get turn rate and set turn rate. Turn, does that say turn rate? Did I make a mistake? I did. Oh my gosh, I didn't even notice that. Wow, that needs to be reconfigured all over. So we're going to refactor, rename to get turn rate. That's going to be a global change actually, because that get turn rate should be something that is in the agent, if I'm not wrong. Okay, that's a note for me to take. I got to make that change. It's a bit of a typo for me. All right, so get turn rate and set turn rate, and then that's what turn rate does. So let's run that thing and see what happens. So when we do that, we should see that now we have our turn rate. We can decrease our turn rate. If I decrease my turn rate low, like something like that, then we're not going to have much control. I can increase my acceleration rate, but notice how my turn rate, it doesn't turn fast enough. If I increase my turn rate really, really fast, it's going to be pretty clunky, right? See that? Kind of clunks along, right? And my max speed, I can reduce max speed again and increase acceleration rate, change my turn rate down to something like this. And you can see that, or even 5 looks to be pretty good. And you can see that that is pretty good in terms of, you know, how it works. If I move this around, you're going to see how it kind of turns around. And this is kind of what Seek does. It kind of goes through, flips around, and goes back. And Seek will never stop. This is not a rival, it's Seek. And if I want to increase the maximum speed, if I do that, so let's say I increase maximum speed to 16, it'll go way out there. So I can do that. I can increase the acceleration rate. And if I did that, if I increase the maximum speed, right, then it's going to really whip around eventually. Now notice that the acceleration rate, it doesn't really do a lot, right? Because what I'm doing is I'm scaling it, right? So I'm scaling it twice, like I talked about before. So in order for us to avoid this, going back to my starship.cpp, remember what this does. Every time I do multiply it by delta time, it multiplies it by 0.16 equivalent, or 0.016. So we don't need two of them. We only need one to give us that scalar. Because we've only done it here, so theoretically, we don't need it over here. And again, we make these adjustments so that it works a bit smoother. And if you did this and go run it again, then you can see now the acceleration actually works, right? It actually accelerates much faster. We can increase the acceleration rate, right? It really works nicely now. It swings around. It's not as scaled as before. And I can decrease max speed to give us that almost exact thing that I want. And this is a much better way of doing things. And all I've done is just remove one of the delta times from the acceleration term. Okay. The lower I make my rotation, the farther it rotates. The greater I make my rotation, the faster it rotates, but it's also looking clunkier because that's like 20. It's way too fast, right? And if I decrease my max speed, I'm going to go right in there. And it's going to do that rotation that is what is normally happening. So this is pretty good, these little adjustments. And what I want now is to do two things. One is I want to be able to reset it over here, and I want to toggle this off and on. So the way to do that, it's a couple steps to this. Let's go back to my playscene.cpp. What I want to do here is underneath all these little adjustments, I want to start thinking about a reset function. And I also want to think about how I want to start this ship off. Let's talk about how I want to start everything up. So toggle seek, let's put this back into play, right? And what toggle seek is going to do is when toggle seek is enabled, right? If my toggle seek button works, right, then I don't want a button for this. Instead, what I want is I want to make this checkbox with an if statement. So I'm going to say if my checkbox is checked, then what I want to do is I want to set the starship enabled M_P starship, and I want to set that it is enabled to set enabled to the M_B toggle seek. So what do I mean by this? I mean that by default, maybe I don't want to enable it. Remember what enabling, disabling does. Enabling or disabling it, if it's enabled, it's visible and updatable. If it's not enabled, it's not visible and not updatable, which is kind of what you want. So when I start my scene in the start function, let's make my ship disabled. And I can do that by saying M_P starship set enabled to false. So it's not enabled by default. When I click on the button, it enables it. Okay, that's one thing that's going to happen. So if I run this now, it's not going to show the starship at all. No starship. But if I click toggle seek, it's going to do it. It's going to toggle it on. If I toggle it off, it's going to stop it. If I toggle it on again, it's going to move back and finish following the motion, right? So here, toggle it off. It's going to freeze it there, and toggle it back on. It's going to bring it back in. So we can toggle seek off and on. But I also want a reset button. I want to be able to reset everything back to normal. And what I can do is I can set up a reset button underneath, pretty much everything else. So just underneath the target position, let's set up a reset. All right, so again, I want a separator for this. And I want to set up a reset. So I'm going to say that if I'm GUI, And I'm going to say if I'm GUI button is reset, if it's clicked, then after the button is clicked, I want to do a bunch of resetting. Okay, I want to reset the starship, and I also want to reset the target. So m_p starship. I'm going to say that is, let's set the transform position. Let's set that to a new GLM vec2 object at 200 and 300, which is where I set it at the beginning. That is kind of our default location on the screen. 200 pixels on the right and 300 pixels down. Okay. The next thing we want to do is let's set up the rigid body velocity. So starship get rigid body velocity. And I want to set that to a GLM vec2 where we want to start off at 0, 0. And then we want to change the current heading. So we want to set current heading. We want to set that to 0, 0, which basically sets my starship pointing in the right direction again. So looking right, okay? And then we want to set the turn rate, P starship, set turn rate. We want to set the turn rate to 5. These are all the initial values, right? M_p starship. We want to set the acceleration rate to 2. Again, these are all the default values we set earlier. And m_p starship, we want to set the max speed to 10.0f. These are all initial values. I also want to set the speed value to 10 because that'll set, this is my UI stuff. So this resets starship, reset starship parameters. And this resets IAMGUI, reset IAMGUI parameters, right? So speed, we also have acceleration rate and turn rate. So we want to reset all those things as well. And what I also want to say is that when I reset the button, I'm going to disable my starship. So starship set enabled, I forgot to do that, to false. Let's put that up here. And down in here, we're going to say toggle seek, m_b toggle seek. We're going to set that to false as well. So we're going to make it unchecked. So that resets the starship, but we also have to reset the target, right? Because that is also something we have to do. Remember, we can move the target around as well, and we want to reset everything, right? So the target, remember, we reset the target, we move the target here with something called target position, right? So we kind of want to do this again, where we set the target position to, a value, right? That's what we want to do. We're going to reset those values, and then we want to set the target position, initially to where it's supposed to be. So let's do that too. So we'll say reset target parameters. This is all the reset stuff. So we can reset things back to normal. We can say m_p target. What we want to do is get transform dot position. That's going to be equal to a GLM vec2 object, which is going to start off again, remember, in 600 by 800. So 600 and 300. Okay, so that's going to be the initial position, and that's what's going to be there. And what we want to do next is we want to set the target position so that these values show up right again as well. So let's just grab this. I'll put that here. Right, so we set it again. Now notice that we can't initialize everything the way it is. We've got to say something like 0 is equal to this, and 1 is equal to this, and that should set everything up again in terms of our target parameters. So that kind of sets everything up there. And that's the reset button. Let's see if this indeed works. I think I've added an extra one of these. Yes, maybe. I did. Yeah, so that should work. Now let's see if this works, and let's go from there. If the variables aren't static, you won't have to reset them. It will get the current position speed. Yeah, I know. But you try it, and you'll see what happens. That's what I thought too. So again, we start this off here, and we have this reset. Notice reset doesn't do anything. But if I click toggle seek, it starts it off. And then I can change the values. We can go back to the maximum speed is 1 or 2, increase acceleration rate. So I can make it do what I want it to do. And then I can change the target location, right? So to follow it, and then that's cool. I can change the maximum speed so it's more reasonable, and increase the maximum acceleration to max, and increase the turn rate if I want to, and the max speed. Going crazy, right? Or I can reduce the max speed, right, and make it dance, or something that looks more reasonable. And okay, I did all these changes. Well, I can reset them. And if I toggle C again, it starts off, okay, that didn't quite work out the way it was, did it? So we changed the target direction, but we never informed the starship. That's something we have to do. So we have to also inform the starship. When we do that, we need to set the target direction to the new direction based on where it's going to be. And that would fix the problem. All right, so makes sense to you guys, right? So this is the IAM GUI stuff. So this is our pretty much seek completed at this point. Okay, let's do that. Let me put this up on GitHub. So we're going to say completed seek. Okay, so commit all, and then again push. So why am I giving you seek? Seek is worth 10 points, and I'm giving you the total algorithm. Well, here's what I'm not going to give you. I'm not going to give you arrive. I'm not going to give you flee. Flee is really the opposite of seek. The other thing I want you to point out to you is this, that inside my starship.cpp, the way the move function is set up, it can only ever do seek, because guess what? It always looks where you're going. It's always doing that. So if I turn this off for now, let's say I don't want to look for where I'm going, and I run it, what will this look like if I'm not looking where I'm going? Is it even going to find the target? These are things that we have to kind of figure out, right? So toggle seek, and I'm not looking where I'm going anymore, and well, is gone. Like, it's never going to come back. If I reset and I toggle seek again, it's never going to come back. It doesn't even look, it's not even targeting anymore. So one thing that we notice is that look where I'm going isn't just looking where I'm going, it's also setting up some additional things. One thing it's setting up is the target direction, right? This piece is the turn. This is the look where I'm going piece, actually. The turn sensitivity and all that stuff, the signed angle, the current heading is me changing my direction. This is my look where I'm going piece, actually. What this is actually setting up the direction. So target, almost like, seek is really what this is. So let's rename this. So seek's kind of not completed. Let's refactor, rename. We'll change this to seek, right? Because the seek algorithm itself, what it's going to do is it's going to do seeking, but seeking also has this piece, and this is the look where I'm going part. So let's take this out. Let's extract this one out. So this will be look where I'm going. Look where I am going, right? And of course, inside of ship.h, we should probably put that in the right spot. So right now we have seek, but look where I'm going is here. Let's grab this and put that here. Notice what it actually gives me is target rotation and turn sensitivity. It actually has two parameters here to get these. So if I look at Starship, I have to feed it target rotation. So that is the target, as well as turn sensitivity. I got to pass that in there for now. That's where my look where I'm going function does for now, right? And these are things that I can probably avoid doing altogether. Target rotation are two things that are going to be calculated. Should I not put this signed angle and the turn sensitivity inside of look where I'm going? I think so. I think this is something that I got to figure out how I'm going to turn. This is just my target direction. I need to set these two things up, but they're independent of this stuff. So let's grab this actually and put these inside of look where I'm going. But I do need my target direction. That is definitely something I need instead. So let's undo that. Let's undo this whole change thing so we can make it better. So look where I'm going. That's nice, Tom. Everything's great, but not really going to work exactly how I want. So what I want to do instead is I'm going to grab all of this and use this to, to change as look where I'm going. Let's try that again. So again, refactor, extract method. We'll call this look where I am going. And when I do that and click next, oh, sorry, I need to save everything. I've done too many refactors. And when I do too many refactors, bad things happen to good people. Let's try that again. So again, we'll do this again, right click, and we'll do a refactor, extract method. Call this look where I am going. And why? Out of line definition of extracted method. I love when I get these funky errors happening. Oh. Yeah, because there is none. All right, so let's do that here. So void look where I am going, and it needs what this needs, which is, sorry, I just got to do it manually. Look where I am going needs what the heck is this? Target direction, which is a GLM vec2. So I need that. I just got to do it by hand because I messed up. All right. That should take care of that. So turn sensitivity, it says, well, turn sensitivity, it's giving me an underline. Usually that means that it says move variable to enter scope. Nah, I don't think so. I like where this is going now because look where I'm going is separated from seek. And now I should be able to turn look where I'm going off, but still do seek. Let's see what that looks like. If I turn this off and run it. Hopefully I didn't break anything. But that's what GitHub is for, isn't it? Worst case scenario. Right, let's see how this looks. So this is no look where I'm going. So let's see what happens now. And that's probably not going to come back. Ever. That's not good. So it's not quite look where I'm going. I know, it's terrible. Yeah. Yeah, it's going to keep accelerating forever. Let's turn down let's actually move it. So let's go back and reset. And let's change the thing to be closer. And then let's make our max speed like really low to see what it's actually doing. So this is what it's actually doing. It's accelerating and it's going to keep going, but it never really hooks back, right? And so why is that? Because I not only am doing look where I'm going with seek, but I'm actually in look where I'm going, there's some really important information, like the target rotation, that changed the direction. And I'm rotating in the direction that my current heading is changing. Whereas if I just do the seek part, it says my target direction is my get transform position, get target position, and my target direction is normalized, right? So that's all I'm getting. Look where I'm going is taking that target rotation and my target direction as an example. That's a GLM vec2 object, and I need to do something with it, which is almost like set current heading. Set current heading. And my current heading, I mean, it's not going to really change other than it's not really going to rotate. It's just going to, wherever my target direction is, that should be my current heading. So although I've separated it, it's kind of really, one thing is kind of dependent on the other. So even though seek is here, look where I'm going, still not really look where I'm going. Let's take a look. So again, we can toggle seek on, and now we can see that it's going to indeed do its turn and do everything that it's supposed to do, right? Let's really reduce this down and move the target in the middle, toggle seek again, and you can see that when I increase my maximum speed to 1, then you can see exactly what it's going to do. It's going to try and turn on a dime and hover around it. If I increase maximum speed, then what's going to happen is, and my maximum acceleration rate, then you're going to get that regular motion, okay? The lower I make my turn rate, the wider the circles are going to be. Okay? And so on. All right, so pretty cool, right? But this, look where I'm going, like we got to really think about what it does. I'm getting assigned angle, turn sensitivity. So why isn't it that then that the actual behavior, the seek behavior doesn't really tie into moving? What's going on with move? How come when I don't look where I'm going, I can't even move there, right? Because, well, get rigid body acceleration is the current direction, and I'm not really setting the current direction until I do this, set current heading. So if I wanted not to use look where I'm going, I could use the current direction to my target direction. Remember, my target direction is a GLM vec2 object. That's what this is, target direction. So, I mean, and that's what current direction is, right? So I could say that set current direction. If I didn't want to use look where I'm going, let's see what happens here. If I say, okay, I don't want to use look where I'm going, let's suppose, and I want to set current direction or set, now again, I can't set heading, but if I set current direction to my target direction, this isn't really going to do what I want it to do. Because my set current direction function, if I go there, it literally just changes that value. That's what it does. It doesn't do the other stuff. It doesn't change my heading. So where I'm looking isn't going to matter. It's just changing my direction. So this might work. Let's see if this works now. So let's see if what happens if I'm not using look where I'm going and I'm toggling it on. Let's see if what happens there. So, right? And yeah, that's what it would do. This is exactly what not having look where I'm going on does, right? If I lower the max speed and I increase the acceleration, it's going to literally do this, right? And that's exactly what it should do. So this is not look where I'm, this is look where I'm going turned off. okay? If I change the direction of where this is, it's going to pop wherever I tell it to go, right? But it's not going to look where I'm going. And Tam, you're correct. So that's what I would have to do if I didn't want to look where I'm going, right? So if that's cool, if I was to, what if, I'm just going to put it out there, what if the move function that I'm defining then, because I want to help you guys, what if I took this look where I'm going stuff and I reset the function here after seek, set current direction is here, but then I look where I'm going in the target direction. Can I do that? Well, target direction isn't something that I can get. Target direction is something that I'm not keeping track of, right, at all. Target direction and get target position, that's a totally different thing. So if I wanted to do this here, then I would have to create getters and setters inside of my starship.h again and do it that way. So again, yes, it can be done. No, I'm not going to do it right now, and just from a time perspective, because I have other things to show you, not this. So I'm just going to comment this out and uncomment this, because this is the right way of doing it, but it's kind of dependent. Seek always uses look where I'm going, and maybe we wanted to turn that off. So we can say something like seek without look where I'm going, right? And this is seek with look where I'm going. Again, you can make a function to toggle this on and off. Okay. So again, just to check it to make sure that it's working, we can press start and toggle it on. We can reduce the speed and increase the acceleration rate. We can see now that it's turning around again. So this is a bit of a change. So we can say that in the commits, we can say refactored move starship move function. So that's what we really did. Commit all, and then push. So I did that. I wanted to show you that because you're going to have to make more than just seek. You're going to have seek. You might have flee, and you're going to have to activate flee or seek or whatever with some kind of state machine, some kind of way of turning it on and off. It could be a button that you're using with, IMGUI. It could be a lot of other things. But I'm showing you that part of seek is already incorporating and look where I'm going, and that's okay. But sometimes we may not want a particle or an object to do this. Okay, so that is seek. Now, what about this obstacle avoidance stuff? Remember, we talked about collision avoidance, and the last part of what we want to talk about, because really what we've done right now is we've covered these two pieces, right? Is we want to cover these two pieces, or these three pieces. So let's add an obstacle first. So, okay, first things first. So again, we're going to go back to we don't need agent anymore for now, and let's get rid of starship just for now, and go back to our play scene. So in my play scene, what I want to do here is where it says add a starship and we add a target, between the target and the starship, let's add an obstacle. So again, we want to try and set that up in placing.h, where we want to say that the game objects are a target, starship, and let's add an obstacle. Right? Now, obstacle, right? Notice that there is multiple choices. It says obstacle.h. We definitely want to use this, obstacle.h, because I've already set it up for you. M_p obstacle is what we're going to call it. All right, obstacle. And in my placing, I'm going to say that add obstacle to scene. Right now, the starship is going to ignore it. M_p obstacle is equal to a new obstacle. We're allocating memory here to make the new obstacle object. And then we're going to say M_p obstacle. We're going to set the transform position position is a new GLM vec2. We'll put it in the middle of the screen, which will be at something like 400 and 300. Okay, and then add child. Okay, now again, you need to make your own sprites, but here's an example of an obstacle, a target, and a starship. Let's see what this looks like when I run it. You'll see the obstacle now, and it should show you the target. All right, well, that's interesting. We activated it, but no obstacle. Well, what happened? Where is the obstacle? Why didn't it show anything? Let's see what obstacle looks like. And let's take a look at that. So we're going to go back to Solution Explorer. We have obstacle.h. It's here. And there's obstacle.cpp, but it uses something called an obstacle.png. And if I look inside of my solution, so if I go to Open File Folder in File Explorer, and if I look at my assets, textures, where's obstacle? It doesn't exist, right? So let's make one. That's why we have no obstacle. So we'll make a simple one, and I'll put this up on a Blackboard for you in a second. So how do you make one? And what do you do? Well, I'm going to make a very simple obstacle using Fireworks or another program of your choice. So here's Adobe Fireworks. And again, any program will do here. Adobe Fireworks is a very old, but yet reliable program. So we're going to say new. I want to make an obstacle that is somewhat reasonable in size. So maybe something that's, elongated. So not, instead of it being exactly the same, maybe something like 200 pixels in size. So maybe a width of 200 pixels and a height of, let's say, 100 pixels. Let's see what that looks like. Am I right? What size does that look like? So it kind of looks like this. And then what I can do is I can make a shape, make it so that the obstacle is red, which makes sense because it's a red, something that you want to avoid. And we'll just make it so it takes up the entire space. And we'll make sure that it's 0, 0, and it'll be 100 by 200, 100 height by 200 wide. And that's pretty cool. But what I want to do is I want to make the border bigger. Let's make the border like 5 so you can see it. And that's what the obstacle looked like, literally just a block. All right, like it won't look very exciting at all. And this is why you have to make your own. Make it more exciting than this guy. So I'm going to say File, Save As, and we'll add an obstacle. We'll call this obstacle.png. I'll save it in my downloads, and now I'll upload it to your Blackboard. So you don't have to do the obstacle for this example. I'm just going to add a new item. It's going to be I'm going to call obstacle texture. Okay, and we'll add the file. So there it is, obstacle.png. Please add this into your into the right place. Obstacle texture. And what I need to do is do the same thing. So when I go back in here, and I want to put it in here, let's go into my downloads where I put the thing. First I want to go into my assets, textures, and I want to drag and drop it in here. So going into my downloads, grab obstacle, copy it, and here paste it. So there it is, this red obstacle. Awesome. And now that I have this obstacle PNG, I can go back to my code, and where it's looking for assets, textures, obstacle.png, it should load. Let's try this out again. There it is. Big obstacle, right? So it needs to avoid this thing. So if I was to enable seek, it's going to go right through now, right? And that's not what we want. We don't want it to go through the obstacle. We want it to collide with the obstacle. And if it has a problem, we don't want it to do this. let's put this in. So we're going to say that in Team Explorer, we're going to go to Git changes. We're going to say added obstacle to placing. Okay, so I'm going to push this up, commit all, and push. And that takes care of this piece. So add the obstacle, like a checklist. Now, AABB collision detection with my obstacle. So I can do, if I collide with my obstacle, let's make some noise, right? So how does this work? Okay. Well, I have a collision manager for you. So if we go to the Solution Explorer, if I look at my collision manager under managers, you notice that in Collision Manager, I have several different collision detection checks. One of them is AABB check, okay, where I can check the two game objects, game object 1 and game object 2, and to see if they overlap. Let's see what AABB check actually does. So go to definition, and you can see what it says. It says, I take my position of game object 1 and position of game object 2, and then it checks to see if one is the target, if the second game object is the target or the obstacle. If it is the target, again, I've already set this up for you, then it's going to make a yay sound. Yay. If it's the obstacle, it's going to make a thunder sound. Where is the thunder sound? Where is the yay sound? Where is this coming from? Well, one thing to note is we need to set up these sounds in the target and the obstacle. So let's go to the target first. So I'm going to go into the target. So this is under game objects. And if I go to target.cpp, you're going to see that we need to make an instance load the sound in here. That's what we need to do. Okay, and the same thing goes with our obstacle.cpp. But here we've already done it. So here's an example of where the obstacle already has the sound loaded. We need to do something like this, right? But instead of the obstacle loading the yay og, we want to make it so that it is the thunder og, and that this is going to be called thunder. So what is og? Og Vorbis. It's inside of assets audio. Let's take a look and see if that's true. So if I go to open the file in File Explorer, we can see that inside there on Lab 3, we can go to Assets, and we can see that in audio, we have a few different files, engine, thunder, and yay. We're going to use thunder, like a sound when the ship collides with the obstacle, and a yay sound when it hits the target. So that's where they are. So I'm going to take this line right here. It's going to currently make a thunder sound. And I want to associate the yay sound with the target. So in the target CPP, just like I did with the obstacle CPP here in the obstacle constructor, in the constructor of the target, just below here, I'm going to say that sound type. Sure. But actually what we want is sound manager. Do I need sound type? I think I just need sound manager. Yeah. So we'll say that this will be yay, and it'll make the yay sound. So when I collide with my target, it's going to make the yay sound. When I collide with my obstacle, it's going to make the thunder sound. And the collision manager itself is going to modify this. I'm using a little switch case to say that if I overlap between the rectangle that is the my object 1 being my starship, and object 2 being one of the two, target or obstacle, it's going to make different sounds based on what you hit. Yay is a good sound, thunder is a bad sound. Please make your own sounds for your assignment 1. This is not sufficient. I'm just using sounds as placeholders for you so that you can see what they do. Okay, let's see what happens when I call the collision manager. The collision manager is going to happen every frame though, okay? So let's try this out. We would put this in the placing. In placing under update, we have, instead of move ship, what I want to do here is call the collision manager. So I'm going to say, hey, collision manager, I want to AABB check. I want to check a axis aligned bounding box with M_P Starship and M_P obstacle, right? I want to be able to do those two things. And I also want to do another check between my M_P Starship and M_P target. But I only want to do these checks if my Starship is enabled. So I can say that if M_P Starship is enabled, that's the only time I want to be able to do these two checks. Because if I try and do a collision detection with my Starship when it's not enabled, I'm going to get a null reference check, and that's not what I want. All right, let's try this out and see if it works. All right. Start. So nothing's happening, and I'm going to launch this and click this, and
yay.
Right? And it's going to keep doing that. I'm not sure if you can hear the sounds, probably not, but
yay.
Over and over again. So let's reset. So that kind of puts those two things over there. And let's see how that's done. And I'm going to share the computer sounds with you in Zoom. Let's see if I can do that now. So I'm going to go into share sound. And so you should be able to hear the sounds now in Zoom. You hear it, Tam? Let's try it again. Right? Here we go. I'm just going to try this out. My little guy is really excited about hearing it again. He hasn't heard that sound in a while. Ready? Here we go. Let's toggle seek. So,
yay.
Right? It's pretty ugly, but it works, right? And it's going to come back around and do it again.
Yay.
There we go. Pretty simple. My little NCL is running around the screen. Here we go. All right, and that's the first part. So that's kind of that part right there. And you can see that that is doing the seeking behavior. And that, my friends, is AABB collision detection. So axis aligned bounding box where two things overlap, to create that very simple collision detection to see if I collide with my Starship and my obstacle, and then checking to see if my Starship and my target collide. You need to do this kind of check every frame for each object in the scene. Okay, that's important. Okay, let's put this up on GitHub because I've just added collision detection for basic collision detection between objects. So Team Explorer, we're almost done here. Git, we're going to say something like added collision detection for each object. Okay, so commit all and then push. So that should do it. Questions so far? I know there's some of you have escaped. I know this is something some of you can't do because it's new and so on, but at least this will give you the most of what you can get with this part. I think you guys are good. Okay, the next part and the last part of what we're doing, because we really did this, we did kind of AABB collision detection, and this is going to start you off on the right path. So what about obstacle avoidance? Remember, what we want to do is do some primitive raycasting, right? And what I mean by that is we can draw a line. We can draw a line between my Starship, and we want to be able to see it, just like we've done in the start scene, actually. If you notice, I already kind of have a ray that I'm casting. Let's take a look. So this is the ray, right? I'm doing this ray cast for my spaceship, right? Spaceship, Starship. So I've kind of given it to you what the ray would look like. So let's just do some simple ray casting first. And let's take a look at the spaceship as an example. That's why I included it. So if you look at spaceship, so there's Starship, and then there's ship, right? And let's take a look at ship.cpp and see what happens. So we have a ship, yay, it's all good. We have a current heading and turn rate, and we have a couple of additional things. We have set line of sight distance, and we have set line of sight color. So those two things we can do, and we can do it immediately. So let's just grab these two lines. And because my Starship is already an agent, and so too is my spaceship, right? So spaceship is an agent, Starship is an agent. I can initialize my line of sight if I want to. So let's do that now. So starship.cpp, we're going to say that at the bottom, And I want to turn this on. Like right now, our line of sight distance is, instead of 400, that's pretty far away, right? Let's make it so it's like 100. Okay, so 100 distance, and that's the distance in pixels. Okay, my line of sight color is red as an example right now because it's RGBA. Let's make this so it's green. There it is. So a green line, and we can turn this off and on when we want to. Right now, we don't have a line that we're drawing, and if you look at the ship.cpp, if I want to draw the line, then what I can do is I can draw my line of sight, but this should only be drawn when I'm debugging, right? So yeah, right? It's going to take my ship's position plus my current direction, and then also going to get the line of sight distance plus the line of sight color, and that's what it's going to do, right? So instead of including it in my ship like I've done here, because I don't want to include it all the time, I want to include this inside of my my scene for now. So again, I'm going to go back to my placing.cpp, and in my draw function up here, what I want to do instead is, what if I said that I want to draw a line between my starship, M_P starship, get transform position, and plus the starship's get current direction, plus my starship's get line of sight distance and the line of sight color, and that's what's going to draw everything every frame. That's going to draw a line in front of me. Let's just break this up because it's a really big long line, and so you can see it in 2 lines, right? So maybe we'll break it up kind of right here. Let's see if that makes it better. It does. All right, so that kind of is drawing a line, which is really, if you think about a line of sight, or think about it, sensing, if you will. But all this does is draw the line, doesn't do anything. Okay, for Starship. All right, and let's see if that works. So we can see if we should get a green line now all the time. And there's that green line, right? Even when the Starship's not drawing, well, neither is this. So if I toggle it on, then you're going to see that green line.
Yay.
And it draws from the center of the Starship out in front of itself all the time. It actually turns with the Starship, okay? So that's good, but I need to make a little check. I need to say that the only time I want this is if the M_P Starship is enabled, right? That's when I want to turn it on. And we may want to not turn the color on at all if we're not in debug mode. I haven't set that up. We can also get rid of some of these other things that we've removed from before because we don't need them. Same thing in the play scene. I don't need to have my move Starship anymore. I think we've, kind of determined that we don't need that anymore. All right, so now if I do that, and if I go back and play, you can see that there's a little bit of a, yes, Kim, it is being recorded on YouTube. So if I start this off and I press toggle, you can see now I have my little line.
Yay.
But it just draws the line, and that's not really what we want for the final. I want to only draw the line
Yay.
when I'm in debug mode. Guess what it's going to do, right? And I'm only drawing one line, not more than one, okay? So I'm not doing all the whiskers for you. This is drawing a single line. This is one way of doing it. Again, I can't give you everything, otherwise I'd be giving you away the entire thing, and I don't want that. It's for you to explore some of this stuff too. All right, so what about turning it off? So remember that the only time that this is going to turn on, if I only want it to be turned on, I can toggle it on and off with IamGUI, right? And I can do it because I can say that when maybe I have a little toggle that I show line of sight. And for me to do that, I would have to set up a variable and then some kind of toggle that looks like this, like we've done before, right? So like show line of sight or show debug lines, whatever you want to call it, okay? Or set debug on or whatever you want to do it, right? So you can see all the debug stuff, like for example, the collider boundaries and all that kind of stuff, which we can do it later on. Again, this is a great place to build from, this lab, and that's why I'm not doing everything with you right now. Okay, so that's one. So then what's next? How do I do the next piece? Well, the next piece is me doing a AABB collision detection between the line, or it's almost like a line-line collision detection. If you look at Collision Manager, I've also given you a line-line check, a line-line check. And if I go to definition for that, line-line basically says, look, I'm going to return true when two lines intersect. I can also do a line rect check, where I do a line and a rectangle, and I have start of the line and the end of the line, and that kind of stuff. And I can return true if the line collides with a rectangle. Okay, so there's lots of really good stuff here that you could use to take this further and to do some of these things. These are all collision checks that I've included for you in here. I can also do a point rect check, but this is the one we want to use, line of sight check, okay, where I need an agent and I need an endpoint and I need a set of display objects, right, as an example. And this line of sight check, what it does is it returns, right, true if the display object list that I sent into it, as an example, notice it says display objects, right? And the target, if I'm actually having line of sight with the target. If I don't have line of sight, then this will return false. If I do have line of sight, then it's going to return true. So this is interesting. This is interesting. So I can do a line of sight check. I've actually set this up for you already to help with what this does. So what does it do? I have two things. I have an obstacle when I do a line rect check. And if I have a line rect check with the obstacle, then obviously my line of sight is false. I don't have line of sight. If, on the other hand, the target, right, in which case the agent, and there is no path node right now, so let's get rid of this piece. Path node doesn't exist. But let's suppose that the agent is the type. That's what I'm checking. It's from agent to path node or agent to obstacle. If it's agent to obstacle, then that's good. So if it's a target, if the thing that's colliding with it is an agent, we're beautiful. We were going to return true. Otherwise, it's going to return false. Okay, so that is a true false. We have line of sight. We don't have line of sight. If we don't have line of sight, we need to turn. Think about this, right? So what I mean is, if I run this thing and if I turn this on, I don't have line of sight. Now I have line of sight, right? Okay. I still have line of sight here because there's no obstacle. I don't have line of sight when I'm passing through this thing. So right now I don't have line of sight because I'm not connecting with it. I do have line of sight, when I'm close to it. So line of sight really is how far you want to cast this line, right? So really it's not a great check to use, but what it does is if I'm colliding with this thing, the line collides with this thing, then there's no line of sight. There's no way that I can get to the obstacle, like right now, right? Okay, and I can turn that on and off. So that's something where you should check. This is a place I'm giving you hints on. I already have something for you. You've just got to plug in these values. So how would you plug in these values? And the last thing I'm going to do with you today. Said not good enough for the assignment. No, it's not. You need to use your own stuff. You need to use your own textures, guys. Like I said, your textures are your own. Don't use mine. All right, so, let's go back to what I'm talking about. So inside the placing.cpp, last thing we're doing today is if you look at the update function, right now what we're saying is, hey, check to see if my starship collides with my obstacle and my starship collides with my target. You can also do another collision check. You can say that, hey, collision manager, I want to do a line of sight check. My line of sight check requires a few things. The agent, M_P starship. It requires an endpoint, right? M_P starship. And then I want to get line of sight distance, right? So get line of sight distance, right? What it does is it does a float. And what I want to do is I want to take the current starship position, right, and add in the distance between the starship in the direction that it's looking at. Okay, so that's kind of something, because that's what the line of sight check needs. It needs an endpoint, someplace at the end where I'm looking. Okay, and if you look here, I kind of did it. It starts at this draw line, starts at the start, and I have the end. So this end from draw line is what I need here. So that is all of this. So that's the endpoint. And then after that, I need a display list. So that is get display list. That is the display list from the scene. All the objects in the scene are going to be loaded into this thing. And then finally, what I need is the target, which is I'm checking to see if I can see or if I'm connecting with my my target, M_P target. Okay, so that is returning a true or false. That's what it does. It just returns true or false. So let's do I don't know, auto can see target, right? Or, you know, I can see the target. If I can see the target, then yay. If I can't see the target, then bad. And let's print it out. So standard see out, and we can say can see target, right, is what I want to output. And let's see if I put a little message out there to say something like, ship is, if the ship is obstructed, right? Ship is obstructed if I can't see the target. So if I'm not close to the target, if this is false, then ship is obstructed, right? So we can say ship is not obstructed. Or we can say is ship obstructed. How about that? So right now it'll start off as false because it's not at the beginning. But if I can't see the target, then it's true. So it'll be either true or false, or 0 or 1 is what it's going to return. Okay, let's see what happens. So, and once we do this, once we know the ship is obstructed, you can respond to that, right? So let's turn it on and let's see what happens. So it says ship is obstructed. It's going to come back. So it's not, it is. See how it turns on again? Ship is obstructed is 0. We're also getting an error. I'm going to come back to that in a second. So it's not obstructed, but now it is. See how it kind of was obstructed for a second? Right there. So that is kind of a way of using line of sight to kind of determine what that is. It's not really accurate, but it's a place we can start. Okay, why? Because it says, hey, take the ship and check to see if I have line of sight with the target. Right now, my line of sight line is pretty short, right? I mean, it's 100 pixels, so it's not going to give us a lot of time to do something. But if I'm colliding between a line, if I can run a line between my ship and my target, right? And again, you can make this line of sight as long as you want. If we don't have line of sight, right, as an example, then, well, we need to start turning. We need to start turning. So if I made this line of sight much longer, let's do it. Let's make it like, I don't know, 600. So going back to my ship. And if I made the distance in pixels to something like, let's say 400, all right? Okay, let's see what happens now. So if is the line of sight obstructed right away or not? And let's see what happens here. So it's obstructed, right? Look, it's not obstructed, right? And then take a look at the line. It's obstructed. As long as this thing collides with this, it's obstructed, right? And you can see what it does. It's also generating some errors. And the reason why it's generating errors is what it's returning, right? So I'm really not outputting the right thing. What I want to look at is what the collision manager does. So it says that, okay, so I got my line of sight check, and it says it checks to see if I'm colliding. And then it says, okay, well, if it's an obstacle, then it's returning false. Then line of sight is false. So now let's change what it says in the placing. So in the placing then, line of sight. So ship has line of sight. That can see the target. Because right now, line of sight means it has to be touching the target, okay? That's different than what I did before, okay? And then in case it doesn't, and it hits, if the target is being hit, not the obstacle, then, and if it's the agent itself, if the agent that is hitting, this agent type, which is this, if it's an agent, if the ship is an agent, which is true, then, and if it's the start point and the end point, if this is true, then we have a line of sight. If not, then we have an error, right? Because switch case, if it's not the agent, as an example, if that's not the thing, if it's some other type, right? Or if one of these two cases don't trigger, then we're going to get this error type that's going to come up, right? Now, here's something. If I don't include the defaults, it's just going to complain, right? That's all that's going to happen. So if I don't include these defaults, it's going to complain, but it's not going to stop functioning, right? So let's try this again one more time. And then you'll see that if I either have line of sight or I don't. Remember, to have line of sight, this line here has to be touching the target, okay, without an obstruction in the middle. So if I turn this on and I run it, then we start off with,
Yay.
I have line of sight, right? Let's take a look.
Yay.
Now it's saying I don't have line of sight, 0, because I'm not touching, right? I am touching, right? Right? I'm not touching. So once this line touches the target, I have quote unquote line of sight. So this is, again, these are tricks. These are just some examples of how you can detect if you have access. Let's slow this really much down so you can see what I'm talking about. If we slow this down to something like 2 and speed this way up so we can accelerate quicker, you can see now we have line of sight, right? Look at that. So why does it keep on colliding? Well, because here's something else I want to point out, that the starship itself is quite long, and we're using AABB collision detection, right? Even though I'm rotating the starship, I'm not rotating its collider, right? So be aware of that when I'm rotating, and because the collider is long, it's not exactly squarish, when I rotate the collider, when I rotate the starship, the collider doesn't rotate. It stays as is. Okay, so keep that in mind as well. We haven't figured that out yet. All right, so that is everything that I can give you today. It starts you off on the right path. I'm showing you that there's some things you can do with line of sight check, and I've given you some code as an example. Your job is to complete the assignment. I think arrival and fleeing is fairly straightforward. I think your biggest challenge is going to be avoidance. How do you do collision avoidance? Or sorry, obstacle avoidance. And the way to do that is by starting to use some kind of line check, which is what I've done here. This is not the solution. This is a point in the right direction, right? The solution would be if you turned away from your, again, from your obstacle by detecting that you're colliding with it, okay? A line of sight check checks all objects in the display list, right? Which is all objects in the scene. That may not be what you want to do. Right? I'm just showing you how line of sight check works. All right, any questions before we go? I know there's a lot here. Hopefully it'll help you with part of the assignment, and I'm looking forward to seeing your solutions for obstacle avoidance. There's a ton of different ways to do it, but it's up to you how you're going to implement. Okay, if there's no questions, I'm going to stop recording this on YouTube, and then I'll see you guys next week. Good luck on your Lab 3. It's also due Sunday. I recommend trying to put Lab 3 out today as fast as possible. Remember, for Lab 3, you need 3 screenshots, and you can select the screenshots that make sense for you, where you want to show kind of the movement of the object, as well as if you want to capture the line of sight stuff at the end, that's fine too. Otherwise, that's it for me, guys. Take care. And I'll see you guys next week. Hit me up on Discord if you have any kind of questions or you need time with me one-on-one. Thanks so much. You always have to use your own sprites and sounds, Lewis. Always. Okay, so hopefully that's clear enough. All right, hopefully that helps. But yes, I'll take that back.